Hey, good afternoon, class. It's 2:30 on April 11th, and we're going to present the full Chapter 13 presentation. For those of you who were in class yesterday, you can start over when I get to slide 24. For the others, you need to watch the entire video. There'll be a couple questions embedded in the video so that I know that you've watched it. So let me share PowerPoint, and we'll talk about systems development. So there's a lot of us seen already where we're going to be looking at building information systems today. We're going to look at how do new systems produce organizational change. We're going to look at the core activities in system development. We'll look at some business process changes as well. We'll look at principles for modeling and designing systems. We'll look at other ways of building a system and new approaches to system development in a digital era. The video cases we're going to take care of in class on the 24th. So no written assignment due. However, as I told the class yesterday, this is an experiment to try to change our process of handling class. And if we get good two-way communication on both video cases, we won't have to write anything. If we don't get good communication, then we're going to write case 2 as well as some questions from our text. So we're going to see that IT is going to be an enabler for organizational change because we're introducing new systems that should match your business process. We do this through a few ways, which we're going to look at again when we do risk-reward analysis of both about these changes. First is automation. It really takes our manual tasks and writes routines in our programs to do those for us and should make us more efficient. Rationalization of procedures. That's where we're streamlining our standard operating procedures or our business processes to make them more efficient. Business process redesign. We look at our business processes, we analyze them, we make them easier, and we redesign based on that second look at our process. Paradigm shifts are where we look at the nature of our business. Maybe we define a new model for our business and we change the nature of our organization. So if you look at our mug company, say 2 years from now, mugs are going through the roof and we can use our business processes to manufacture, say, computer mice, basic same shape. It's now a paradigm shift though, because now we're making computer equipment instead of drinking mugs. So if we look back at automation, we see replaces manual tasks. That's a low risk, low reward activity for Rostamunk. So we may not waste our time automating some processes because we're not going to get much back. Looking at rationalization again, we streamline our operating procedures, continually making improvements in our product. Medium risk, medium return, we're going to more often than not do that one. Redesign, looking at our business processes, our workflows, combining steps, eliminating repetition, having better relationships between our applications and our databases gives us a little higher risk, a little higher return. We're going to do it as well. A paradigm shift, we're really changing our business. This high risk, high reward, something we may not be able to do at Rostamunk, but a company like Yeti might, where they have the wherewithal to sustain a new business model and look at the risk behind it. Think back to the Walmart video we seen a couple weeks ago where they would just buy companies to try to compete with Amazon, and they didn't care if they failed or not because there was a blip on their radar. So BPM, Business Process Redesign. We have a variety of tools, different ways to analyze and optimize our processes. We can use testing tools to model a process and see how it works. We can manually do a process. We can use existing systems and see how they manage a process. Steps in process management. We have to know what we want to change. We're going to analyze that process. We're going to design a new process, implement it, and continuously measure it. We'll see this kind of falls in line with our thinking on systems development lifecycle, and we've seen it a little bit in our decision support chapter, enabling decisions in our decision process flow. So here's a process for buying a book from a bookstore. We had some lively discussions on this yesterday. Sorry to those who missed it. But for those of us that go down the hill to the bookstore, we go to the bookstore, we look for our text. Do we find it? Yes, we buy it, we bring it home. Otherwise, we ask someone for help. If they find it, we buy it, bring it home. Otherwise, we order it, or we go to another store. If we order it, we have to go back to the store, buy the book, and take it home, and our clerk will let us know when it's in, of course. Quite cumbersome, a lot of walking, a lot of dealing with people. We're under the constraint that when the bookstore is open. Now, let's look at the internet. Our great friend, low cost, high speed. We're not buying our book online. We go to Amazon, we look at the ISBN. Is it available? Yes, we order it, we get it in a couple days. If not, we go to Barnes & Noble. It's a much simpler process than buy it from a bookstore. So this redesign may be a little risky. We're going to get a lot of return back, but we're going to do it. Excuse me. Tools for business process management. We're going to identify inefficiencies. We're going to create models to improve our processes. We're going to capture our business rules, raw performance, and automation. We're going to integrate our changes in the process with our existing systems and monitor them for the systems we may build. We're going to verify we've improved our processes and measure them against KPIs, key performance indicators. As I told the class yesterday, the next few slides are about 20% of our final exam. Not a final per se, it's maybe 4 or 5 questions on chapter 13, 14, and 15. But this I introduce as the systems development lifecycle. It's how we build our system. It's systems analysis, it's systems design, it's programming, it's testing, it's conversion, it's production and maintenance. All things we'll discuss with the help of our slides. In class, we kind of did it without our slides. Systems development is a cyclical approach, one that I believe never ends. So we start at analysis, go to design, programming, testing, conversion, production, and maintenance. I believe since we're always looking to maintain, enhance, give new functionality, and fix our product, that the circle should be closed and it continually spins. So what is system analysis? It's defining a problem, identifying why we have a problem, looking at solutions, and identifying requirements to meet those solutions. Oftentimes this stage comes with a feasibility study. Hey, we know we have a problem. Here's some solutions. Now, can we afford it? If we can't afford it, we have our project managers in charge of this whole systems development life cycle write a system proposal report. It will include information requirements, cost, resources needed, technologies to use, etc. System design. That's the nitty-gritty of our entire process. We're going to describe how our system is supposed to work and what functions we're going to have that we learned during system analysis. It it should address every area of our hierarchy. It's key to note here, and you'll lose a good 5 points if we don't remember to include it, is the role of the end user. Our users' information is required to drive our system building. We have to give our users control over the business process, the design process, to make sure their priorities are met. And insufficient user involvement is a major cause of failure. So, first question to those who weren't in class yesterday. Not a great night on the soccer front for me, and I was watching the CONCACAF Champions League, and my team, the New York Red Bulls, lost to Chivas de Guadalajara. So Chivas de Guadalajara goes on to play Toronto FC. So your question is, who's in the final of the CONCACAF CONCACAF Championships? It's Toronto FC versus Chivas. Weird question, but it's really who I am. Here's some things we look at design. What are our inputs? What are our outputs? What's our user interface going to look like? Is it going to be simple enough for our CEOs and expert users to use? Will it be intuitive enough for our operational users to use? What's our database going to look like? How are we going to process data to information? Do we have any manual processes? Do we have any controls over the way we handle it, input or outputs? Security. Who can access our applications? What happens if something goes wrong? Will we be audited? What do we have to give to auditors? What documentation do we have in place? What procedure are we going to use to take a newly tested application and convert it to production? What organization changes may happen as a result of our new system? Programming is simply the process of taking a programming language like Visual Studio.NET, C++, HTML, Java, just to name a few, and creating an application that will access our databases to process data and give a page for a user to work from. Testing. Key part of any systems development lifecycle. We have to see if something works. So we do things in a few ways. Within the IT department, we'll handle unit testing and system testing. Unit testing is we take a piece of a program and test it as a system. And then if we're open with that unit, we move on to the next unit and test it. Then we test the system in its entirety. After we have a system that's working, we go to our users. Remember here the importance of end users. End users happen here again in testing before we convert our application, in that acceptance testing or user acceptance testing, make sure those stakeholders have tried the application that does what it has to do. This is an example of a test plan. The next to last stage in the SDLC is conversion, the process of moving from the old to the new. A few viable strategies and parallel strategies where we run the old system along with the new one. Direct cutovers where we shut the old one off and launch the new one. A pilot study is where we have pieces of our application move forward. And phased approaches, we give it to one set of users, then another, until we finally have it launched everywhere. I typically run with parallel strategy. Production and maintenance. Production is the stage when conversion is ended, and we'll continue looking to see if we need revisions to our application based on new functionality, better documentation, problems with our hardware or software, or problems with our application itself. Maybe it's not running calculations properly. That need for always enhancing our product and looking for problems is why I believe maintenance never ends. So to wrap up the SDLC, analysis, we identify problems and solutions. Design, we design our application. Programming, we build it. Testing, we make sure it's going to work both at an IT level and user level. Conversion is we take our developed application and move it into the greater population, known as production. Production and maintenance, we operate the system, we continue to look at it and modify it. Here's where those who were in class yesterday will start, and that's with structured methodologies. So techniques are step-by-step, they're progressive, they move from one phase to another in structured programming. Process-oriented, however, we focus on modeling processes and how we can manipulate data. We do so with data flow diagrams. We've introduced data dictionaries already. It identifies our data flows, our data stores, our entities, our relationships, our attributes. Process structures describe the transformation occurring from the lowest level of data upwards. This is a data flow diagram on how we would register for a class at a college. A student goes in and requests their courses, and our next phase is, are the courses available? If it's available, we enroll you, and then we confirm your registration. If you reject it, we go back and tell you you're not accepted, and then you look at the courses again and try to get your file again. Once you've been enrolled, we write it to your student master file where you get your schedule. Structure chart kind of looks like a hierarchy, and so we look from a top-down approach for process and payroll. That's our application. So we get our inputs, and we make sure they're valid. We calculate gross pay and net pay, and then we get our total pay. We update a file, we write checks, that's our writing our outputs, and it all rolls under our payroll process. Object-oriented development's been around for about 30 years, and it's based on an object, a basic unit of design. It combines data and the processes that operate on those data that transform that data. Data in the object is accessed only by operations associated with that object. So OOM is based on concepts of class and inheritance. And we see here by class and inheritance. So we have 4 entities: employees, salaried, hourly, and temporary. And we see the salary, hourly, and temporary are all classes that get inherited from pay. This type of development is iterative and incremental. It's pointing out that objects are reusable. That's why we got into object-oriented development to begin with, because we have less time in needing to code applications because we have code that we can reuse, and it cuts down costs a great deal. Looking at OO again, system analysis, we look at interactions between the systems and the users. Design describes how the objects are going to behave. And implementation are knowing that some classes are going to be reused from what we've done before. Case, we're not going to spend a lot of time with. I've never used them in my career thus far, but they're tools that automate development. They get rid of the repetitive work. They're iterative, but they require a great discipline to be able to use them efficiently. Our systems life cycle. The oldest method from building our system is based off the systems development life cycle. It's a waterfall approach. One stage finishes before the next begins. There's a formal division of labor between users and IT. It emphasizes specifications. It's still used in building complex systems, but it's costly. Not very flexible because we don't move from one stage to another. It's kind of what it looks like. We do analysis, then we do design, then we do programming, then we do testing, then we do conversion, then we do production. What's different than the cyclical approach to systems development? where today in 2018, all this kind of happens concurrently. Prototyping. You've probably heard of prototypes with things like cars or other means of transportation. It's an experimental system that we can build quickly and not a lot of money is spent. It's a working version so our users can see the basic functionality is going to work. And how we build a prototype is we look at our users' requirements, we develop and use the prototype, and then we revise it and enhance it based on feedback we've gotten from the users who have used the prototype. And here's the flow of how it works. We have requirements, we have a prototype, we use the prototype. Are we okay with it? We develop another prototype of greater detail. Otherwise, we go back and see what's going on with the prototype and redevelop the one we've already tried to launch. Advantages. We use them a lot when we're building the front end of our application, the home page, so people can get a touchy-feely type experience with it. We want to make sure we fulfill the user's requirements the first time. Disadvantages. We may miss some things because we're looking to build only a small piece. End user development is simply where you, as our class, our end users at Rasta, we let you build your own systems to match a need that you have. They typically use things like Microsoft Access, Microsoft Forms and Access, all single user stuff, or some query languages like SQL that are pretty easy to use to have some reporting given to them. That's really based on your time and what you have available to make your own system. It's not really IT involved. So we have rapid completion of projects, great user involvement because it's all user environment. But it's not meant for more than one person's use. We have really no control over the data, the quality of the data. We have no management control and testing of the application itself. We may not be able to justify the cost or the work lost because the user has developed their own application, and we may not have standard infrastructure to handle or warrant an end user developed system. So buying a package or buying software that's cloud-based really saves us money, and we have the functionality to customize. Like I'm doing now at Greystone, we're buying a new financial accounting package, which will scale to be an entire ERP. But we're starting with finance. We can customize it to match our general ledger and accounting processes. It's entirely cloud-based. So I don't have to have servers at my location here in Hopewell Junction where I'm recording our video during a break. And that's our second question. I'll record the video on break at Greystone at Hopewell Junction. Typically, when we look at software packages or cloud services, we may get requests for proposals, or we may look at vendors based on research we've done. Then we really bring them in, have them run their prototypes, their demos to see what functionality most attracts us to them, and then we make a decision based on functionality and cost. Outsourcing. I spent the last 7 years of my career at Sequoia outsourcing. And I've outsourced a lot of work here at Greystone because we have 2 people that work IT. We can't possibly have the time to manage our servers, manage our applications, manage our network, our firewalls, our security. Some of which we do, some of which we've outsourced. Like I have all my servers in the cloud now, so I don't worry about those. I've outsourced my security to a vendor that just handles security, so their technicians manage our firewalls, which they're doing right now for us, and they're doing some upgrades for us right now. It's just things I don't typically have time to do. Domestic outsourcing is really our need for that skills that we don't have in-house. If we look to, say, India or Mexico for offshore outsourcing, it's really price-driven. The labor in those markets are much cheaper than they are here in the States, and we get good quality work for less price. We do deal with language barriers, time differences, all which makes it a little difficult to manage, but it can be done. Agile development is really new in the game of application development, as is RAD and JAD. Rapid application development is creating a workable system in a short time using automated development tools like are available in yes, I'm on a meeting right now. Sorry about this, someone else wanted to use my room while I had it booked. Joint application design is used to accelerate information requirements and develop initial systems design. Agile development works along with RAD by breaking a large project into smaller ones. (2018) is all about mobile application development, building on mobile websites or mobile web apps, native apps for Android and iOS, and to look at smaller screens, keyboards, ways people use their fingers differently, different memory and processing. And that's it. So that's our chapter 13. Remember to get me those results. I'll put them as an assignment within iLearn, and we'll catch back up in 2 weeks where we'll look at chapter 14. We'll have our presentations for chapter 11, 12, 13, and 14. We'll look at the cases in chapter 13 and 14, so be prepared to talk in those. And we'll use most of the class time next time. So again, thank you for your attention, and we'll see you soon.